सिंगर ਹੁੰਦੇ ਵੀ ਬੜੇ ਰੱਦੀ ਗਾਣੇ ਅੱਜ ਸਟਾਰਟਿੰਗ ਕਰਦੇ ਆ ਹਨਾ
ਹਾਂਜੀ
ਮੇਰੀ ਤਾਂ ਪ੍ਰੇਮ ਢਿੱਲੋਂ ਦੇ ਪਹਿਲੇ ਗਾਣੇ ਦੋਵੇਂ ਬੜੇ ਹਿੱਟ ਹੋਏ ਇਹਦਾ ਪਿਆਰ ਬੋਲਦਾ ਤੇ ਉਹਦਾ ਸੋਲ ਟੂ ਨਹੀਂ
Okay. Well, it's 9 o'clock. We've got 20 out of 25 here, so we may as well get started. We're still talking about chapter 6, and we're looking at part B. So let's start with the whiteboard. Before we get started with chapter 6, actually, let's talk a little bit about the tests that we're going to write on Friday. So it's compound interest assignments, 7, 8, and 9. And chapter 5. So "15 questions on chapter 5, 10 questions on compound interest." Sometimes it's a little tricky to read these questions and know exactly what it is you're dealing with. So it might be useful if you're aware that there'll be 3 questions from compound interest 7, 3 questions from compound interest 8, and then 4 questions from compound interest 9. So this one is perpetuities. Compound interest 8. Let's figure out what exactly that was. Was deferred annuities due? And compound interest 7 was ordinary So that just gives you a little bit of framework about how that test is going to work. Most of the test, of course, is on chapter 5, because chapter 5 had we spent 3 weeks working on it. So it's got trade discounts, cash discounts, markup, markdown, and integrated problems. But the compound interest questions, it might be helpful to know that the first 3 are ordinary deferred annuities. The next 3 are going to be deferred annuities due, and the last 4 will be perpetuities. So does anybody have any questions about the test that they need to ask at the moment? One question was, will there be a 24-hour window? Yes, indeed, there will be. From 9 a.m. Friday to 9 a.m. Saturday. And you can pick any 3-hour block in that window, just like the other 2 tests. Any other questions that you can think of asking now? If you think of questions between now and Friday, don't hesitate to send me an email. Okay, well, we'll save that and clear that. And let's take a look at part B, total sales dollars. So as I pointed out the other week, I divide chapter 6 into two parts. One part being what I call units and price, where we really only have one product to worry about. And then this part where we have total sales dollars, where there's many products and many prices. And so they're giving us information about the whole company here. They're telling us sales, total variable cost, fixed costs, and total cost and net income. So the first thing we need to do is understand the basic relationship between these numbers they're giving us. So sales, and then they have total variable cost and fixed costs. And sometimes they'll just refer to this as variable cost. And sometimes they'll refer to this as total fixed costs. I don't know why they're not consistent, but this is what they're dealing with. And then they come up with total cost and net income. But these three here are the important items, because we could get total cost. Total cost equals total variable cost plus fixed cost. In other words, if we added these two, it would equal this. So they didn't really need to give us total cost. If they've given us total variable cost and total fixed cost, we could figure out total cost on our own. And the same with net income. Sales, which is really our total revenue, minus total cost, gives us net income, which is just another way of saying profit. So we already know, we already could figure out net income ourselves, but remember, net income is profit and sales is total revenue. So profit equals total revenue minus total cost, or in the terminology of this chapter, for some reason, sales minus total cost equals net income. I don't know why they've changed the wording, but it's the same concepts. So keep those relationships in mind. These three are the important ones. We could always figure out those two ourselves. When we did break-even analysis in terms of one unit or one price on one product, the important concept was contribution margin. And we have the same situation here. So we're going to calculate the contribution margin. So the contribution margin equals 1 minus the total variable cost divided by sales. And understanding this ratio here is very important for understanding how this whole concept works. Remember, in the previous chapter, we calculated contribution margin as sales minus variable cost. And here, our total variable cost divided by sales gives us a decimal value. And what this decimal value represents is how much of every dollar we've spent on variable costs. And so we take $1 and then subtract the amount we've spent on variable costs, and what we've got left over is our contribution margin. In other words, out of every dollar, how much is contributing to our financial well-being. In the first half of the chapter, we took the price of the product and subtracted the variable cost of that particular product. And what was left over was our contribution margin. So we're doing the same thing in this chapter, or in this half of the chapter, but we do everything in terms of $1. So we take the total variable cost, and let's actually put some numbers into this now. 1 minus our total variable cost is $324,000. So that's how much money we spent on our variable costs. And the total amount of money we bought in was $720,000. So I need a calculator. 324 divided by 720 gives us 0.45. So what we can see here is that out of every dollar we bought in, we spent 45 cents on variable costs. And so what we've got left over is 55 cents. So we're talking about our contribution margin in terms of every dollar we bought in. Whereas previously we talked about the contribution margin in terms of every individual product we sold. But as we're only selling one product, that made sense. Here we're selling many products at many different prices. So we can't talk about contribution margin in terms of one product. It's got to be in terms of $1. So $1 minus 45 cents that we spend on variable costs, what's left over is our contribution margin. And so that would be the contribution margin as a decimal value, would be 0.55. But notice, they also want us to calculate contribution as a dollar amount. So what they want us to do is to take the contribution margin we just figured out. So contribution margin equals 0.55. And they want us to multiply it by the total amount of dollars that we bought in. So CM equals, and notice how I've used the small letters for the contribution margin as a decimal, and I'm using the large capital letters for contribution margin as a dollar value, because we have to keep the two separate now. So contribution margin times sales. So the contribution margin was 0.55, and our sales were 720,000. So what this is going to do is tell us how much money we spent, or no, how much money we have left over after we have paid our variable costs. So let's figure out what that is. 0.55 times 720,000. And I'm getting 396,000. So someone has asked, what does contribution margin actually mean? What the contribution margin is how much money you have left over after you've paid your variable costs. So for the previous part of this chapter, we calculated the contribution margin as the selling price of the product. Let's say the product sold for 10 bucks minus the variable cost. Let's say it cost us $3 to produce the product. So we would take 10 minus 3 equals 7. And that's the amount of money that's contributing to our financial well-being. That's how much we have left over after we pay our variable costs. In this case, we calculated total variable cost divided by sales, came to 0.45. And if we think of everything in terms of why can't we directly minus variable cost from sale? In this case, yes, we can. We should be able to get exactly the same answer. Contribution margin, in this case, would equal sales minus total variable cost is 720 minus 324 equals 396,000. Yeah, you could do exactly that. The reason I need to show you how to do it this way is because I'm trying to make sense out of this number here, because we need to use this number. Remember in the previous chapter, our shortcut to finding the break-even was fixed costs over contribution margin. And in this half of the chapter, it works exactly the same way. Our shortcut to finding break-even is fixed costs over the decimal value of contribution margin. So if you need to find the contribution margin as a dollar value, you can do it this way, and you can do it this way. It's a good idea to do it both ways, because then you know that you've got this decimal correct. So the last thing you need to do here is find the contribution rate. The contribution rate. And the contribution rate is the contribution margin, the decimal value of the contribution margin, times 100%, basically. And so we would get 0.55 times 100 equals 55%. So once you know the contribution margin, you automatically know the contribution rate. Because this was already out of 1 and this is out of 100. So this number can be translated into a percentage very easily. So in terms of these answers up here, this was 396,000, and this is 55%. percent. So understanding this concept here and what that means is really the key to understanding everything we're going to do in the second half of this chapter. So any questions on that, how to calculate that contribution margin as either a decimal value or as a dollar value? And okay, that's good. Let's now use this. So let's take a look at this one. So they've given us the same information here. They've given us sales, total variable cost, fixed cost. They've added these two up and come up with total cost. And then they've gone sales minus total cost to get net income. And I say always calculate the decimal value for the contribution margin first. So let's do that. Contribution margin, the decimal, is 1 minus total variable cost over sales. So 1 minus, what was our total variable cost? 16,000 over 40,000. So first off, we have to find out what that is. 16,000 divided by 40,000. That works out to 1 minus 0.4. So this is just going to be 0.6. So remember what this tells us. Out of every dollar, we've spent 40 cents on our variable costs. So we have 60 cents left over. It sounds like profit, but it's not quite the same thing because we still haven't paid our fixed costs. But that's what we mean by contribution margin, what's left over after paying our variable costs. So then they say state the revenue function. So total revenue, and people find this one annoying. Total revenue just equals X. And let's define what this X is. Equals a variable level of sales dollars. So that's all we can do. We can't do price times quantity like we did in the first half of the chapter because we have lots of different prices and lots of different quantities. So just remember that this mysterious X is just a variable level of sales dollars. Total cost. So that's our revenue function. That's all there is to it. Total revenue equals X. The cost function is a bit more complicated. It's fixed costs minus total variable cost over sales times this mysterious X. Oh, it's actually plus, that'll help. And we've already calculated this. So this becomes fixed cost, which we know, 12,600 plus, we've calculated this as 0.6x. And so that's our cost function. Total cost equals, and they want us to put the numbers in here. And so what we're going to do to find break even is we're going to set total revenue equals total cost. So that becomes X equals 12600 plus 0.6x. And this X has to leap over. Yes.
So total variable cost divided by sale is equal to 0.4.
Oh, yes. Yes, you're quite right. It's not the contribution margin. Thank you. That'll help. We'll get the 0.6 in a minute. I was getting ahead of myself there. This 0.4 has to leap over. So we got X minus 0.4x equals 12600. And then X minus 0.4, that's where the 0.6 comes in. X equals 12600. And then we can divide through X equals 126,600 over 0.6. And we can see what that equals if we have a calculator. And I'm getting 2,100 or 1,000. Now notice, though we did all this work here, but we didn't really need to do all that work. We could have just done X equals fixed costs over our decimal value of our contribution margin, which, as we'd already figured out the contribution margin, that it would have been easier just to go straight to this. But I wanted to go through this little piece of painful math here so you could see why this formula makes sense. So that would be our break-even point. But they want us to calculate the break-even point in sales dollars. So total revenue equals X, which means total revenue equals 21,000. Because this is our value for X. It'll be a little more difficult finding it in terms of cost. So fixed cost 12600 plus 0.4x, which becomes 12600 plus 0.4 times 21,000. And let's see what that equals. they should equal the same thing. 21,000 times 0.4 plus 12600, and it does indeed equal 21,000. So calculate the break-even point in terms of sales dollars and cost. 21,000 and 21,000. If we're not rounding anything off, these two should be equal. So then they want to calculate the break-even point as a percent of capacity. And we can see that up here in the original question, they've told us capacity per period is sales of 70,000. So when we are going to calculate percent of capacity, we're going to take, this is going to be equal to X that we've just calculated over our capacity. So this is equal to 21,000 over 70,000. And times 100. Let's put the times 100 in here. And it equals 30%. So that's all the calculations we've been asked to do there, but they have come up with that annoying last question to draw a break-even chart. So we'll do the same thing we did in the first half of the chapter. We are looking for the same 3 points. In other words, we're going to consider the total revenue function, and we're going to consider the total cost function, and we're going to draw this same strange symbol that looks like we belong to some strange religious cult. And we're looking for the same 3 concepts. We're looking for when we're at 0, when we're at break even, and when we're at capacity. We're still looking at dollars in this column, but in this column, we have a problem. We don't have any quantity. What we're going to be looking at is percent of capacity. So now we have to consider our equations. We have total revenue equals X here. And we have to logically figure out that if we're at 0% of capacity, in other words, if we're not selling anything, we'll be bringing in 0 revenue. We've just calculated on the previous page that our break even was 21,000. And in terms of percent of capacity that they got us to calculate, that was 30%. And they told us that the capacity sales dollars was 70,000. And we have to sit and think logically for a minute and consider that this must be 100% of capacity. So we don't have to do any calculating at all to figure out these 6 values because we already know them from the previous calculations. So now we have to do the same thing for total cost, which equals 12600 plus 0.4 times X. And if we are not producing any units, this term here will equal 0. So at 0% of capacity, but whatever it is we had to buy or rent to start this business, we've had to pay our fixed costs anyway. So this is going to be 12600, right? This is going to be our fixed cost here. We already calculated that when we were at a cost of 21,000, that was at 30% of capacity. And we know that this is going to be 100% of capacity. The tricky part is figuring out this. And what we have to do is we have to take this equation down here, but we have to put the 70,000 into this equation. So total cost equals 12600 plus 0.4 times 70,000. In other words, what would our costs be if we were producing $70,000 worth of revenue? So 0.4 times 70,000 plus our fixed costs of 12600. I'm getting 40,600. So this is the tricky one to figure out here. We can't just put 100 in here because 100 is a percent. We have to put the sales dollars at 100 in here to get this value. But this is the one that people get very confused over how to calculate. But just think about what we're doing here. We're trying to figure out what our costs would be if we were at 100% of capacity, meaning if we were at $70,000 worth of revenue. So we have to plug it in here. Once we have these 12 numbers, producing the chart is much the same as we did. Let's take a look at how we would do that. And of course, you're very lucky. Perhaps it's luck, I don't know. You don't have to do any of these on assignments or tests because I haven't figured out how to make you do them on Moodle, although I'm sure there is a way I could do that. But let's hope I don't figure that out. So this up here is going to be dollars, representing total revenue and total cost, which is the same as we did earlier. But this one here is percent of capacity. And so when we're trying to figure out what our axis looks like, this one down here is always going to look the same. It's going to go to 100%. So we can fill that in before we even look at anything else. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. This one here, we need to look at our numbers and we've got to go up to 70,000 So I guess I'm going to go up in 10,000s. 10, 20, 30, 40, 50, 60, 70. And whenever you fill in, whenever you're going to use a number, make sure you put it on the diagram. So we can try and put in our first point on this, and we'll put it right there. And of course, we know the first one is right down here. Let's find the ones in the middle, 10, 20. So 21 will be somewhere like here. And that's at 30%, which is 10, 20, 30. So we can fill that one in. And then you need to take a straight edge and see how well they line up. And they line up incredibly well, which is nice. And whenever you put a line on a diagram, always put a label on it. A line without a label is ridiculous. So we have our total revenue, and then we've got to do the same thing for total cost. We started at 12,600. So here's 10, 11, 12, 13, somewhere vaguely like here. Keeping in mind, it doesn't have to be a work of art, or they wouldn't let me teach this course. We've already got this one. And now 40. So 10, 20, 30, 40, 600. So just slightly above the 40. 4,600. And this is at the 100%. And take your straight edge and see if they connect. Not too bad, not great, but not too bad. And put a label on it. Total cost. And there's various things we want to do here. We want to draw people's attention to this point here, because this is the important point. This is our break even. And in this area, we'll be making a profit. And in this area, we'll be making a loss. So when you try to produce a business plan for your company, and you're trying to convince people to loan you money, somewhere in your business plan, you'll have a diagram that looks something like this. And you'll be drawing people's attention to the fact that there's lots of room for profit in this business venture, and they should lend you money. So any questions on what we did there before we throw all that away and look at something else? Okay, I'll take that as a good sign, and we'll save that. Clear it. We'll clear that. Clear that. Okay, let's take a look at what else they've done to us here. So they want us to work with the relationships between these numbers. They've told us that net income for Abracadabra Magic Store last year was 178. So consider this framework here. We start with sales. We have total variable cost, fixed costs, these add up to total cost, and then sales minus total cost is net income. But they've told us that net income equals 178,000. They've also told us fixed costs. So fixed costs is 151,200. And they want us to figure out what sales were. But given just this information on its own, we don't have enough information to do that. But they have told us the contribution rate equals 27%. And we know how we got contribution rate. Contribution rate equals the decimal value of the contribution margin times 100. So we can figure out the contribution margin is simply let's write that properly, 0.27. So we now know our contribution margin was 0.27. Now we had a formula that we worked out that said the break-even level of sales equals fixed costs divided by the contribution margin. But this is break even. So profit or net income equals 0. And so at this point, they expect us to somehow realize that we can change this. We can have any level of sales, not the break-even level of sales, just any level of sales. Remember, this X is a random level of sales dollars, could be equal to fixed costs plus net income divided by contribution margin. And I don't know how many people would struggle to come up with this concept after reading the textbook and banging your head against the wall, but I've put this on the formula sheet so you don't have to kill yourself to figure this out. So they've given us fixed costs. This is the information they've given us of 151,200 plus 178,000 over the contribution margin of 0.27. So once we've come up with this formula, we can actually figure this out. So 151,200 plus 178,000 divided by 0.27. And we get some ridiculous number, 1, 219, comma, 259.26. So that's what the sales must have been when they were making profit or net income of 178,000. But the important concept is this thing right here. That our break-even level of sales is fixed costs divided by contribution margin, but any level of sales can be fixed costs plus or minus. They could have been making a loss, and we could still calculate sales by adding or subtracting their profit or loss from their fixed costs divided by contribution margin. So I just wanted to take a look at that question, because once you've seen the formula, of course, it's easy to solve. Coming up with the formula, if you don't know the formula, is not easy. I'm sure some of you could have figured it out, but it's easier to look on the formula sheet and just use it. So any questions you can think of asking at that point? Let's take a look at the next one they've tried to confuse us with. So we have Henry, or I guess if you're French, it would be Henri or something. And Henri's business budget included sales of 416,000 and fixed costs of 79,800. So we know sales equals 416,000. We don't know total variable cost, but we do know fixed costs is 79,800. We have total costs that we don't know, and net income that we don't know. So again, they haven't given us quite enough information here, but they have told us the contribution margin for the business was 145,600. So in this case, they've given us the dollar value of the contribution margin. And how does that help us? We know how we got this contribution margin. This dollar value, contribution margin, equals sales times the decimal value of contribution margin. Or we could look at it another way. Would that be easier? The contribution margin equals sales minus total variable cost. So that might be the easiest way to look at it, because we know the contribution margin, 145,600 equals 416,000 minus total variable cost. So total variable cost equals 416,000 minus 145,600 600. So that should give us our total variable cost. Let's try that. 416,000 minus 145,600. That would give us a contribution margin of 270,400, which we could fill in here. And I don't know whether that helps us or not. Because now we could add these two together and get total cost. Which would be 352,000. And we could take that away from sales. So we'd be getting net income or profit of 65800. Now, what they've asked us to do is find the sales needed to break even. We can see we're not breaking even because we're making a profit, but at least we have all these numbers and we could figure out our break even equals fixed costs over the decimal value of contribution margin. So we still need to find the decimal value of the contribution margin. And so that would be contribution margin equals 1 minus total variable cost over sales, which would be 1 minus our total variable cost of 270,400 over 416,000. Let's see what all that nonsense equals. I'm getting 0.35. And so this would be 1 minus. Oh no. I've actually calculated the contribution margin there. So that's okay. So up here, we would go fixed costs, 79800 divided by 0.35. And what would we get? 79800 divided by 0.35. We'd be getting 228,000. So that would be our break even. Now somebody's asked, how is net income calculated? Let's define that. Net income equals sales minus total cost. We didn't use CM equals. No, we down here, I used the 145,600 and we calculated our total variable cost in this manner. We could have calculated it up here. Let's go back up here and take a look at the first thing I was trying to do. We could have done 145,600 equals sales 416,000 times contribution margin, which we didn't at this point know. And so we could have calculated that the contribution margin equals 416,000 divided by 145,600. And we should get the same answer that we got. 416,000 divided by 145,000. And I got some ridiculous number. Why did I do that? Because I divided it the wrong way. That's what I did. Let's get rid of that. Try that again. 145,600 over 416,000. See if we get any better answer. 145,000. Oh no, 145,600 divided by 416,000. And we do indeed get 0.35. So because we have two ways of calculating the contribution margin, the dollar value, we had two ways of doing this question. We could have done this to get the contribution margin, or we could have done all of this down here to get the contribution margin. In both cases, we came up with a contribution margin of 0.35. Once we have that contribution margin, then we can calculate the break even, because we're going to do fixed costs divided by the dollar value. So our final answer here is 228,000. So yes, I distinguish between the dollar value of contribution margin by using the capital letters, and the decimal value by using sort of the small letters. I just need to keep them separate, or have some way of knowing that I'm talking about the decimal value or I'm talking about the dollar value. So I just use the capital and the small letters. You could do it either way, or you could do it any way that makes sense to you. I just find that to be the easiest and simplest approach. So with that question, the key, of course, was finding the contribution margin. But as you can see, we've got two ways of doing that, and they both work out to being exactly the same value. So let's take a look at what else they've inflicted on us here. So Joy's cupcake business had a budget of 192,000 in sales. That's a lot of cupcakes. And 99,840 in total variable cost. What is the most her fixed cost could be for the business to break even? So again, consider the information we're being given. We have sales equals 100 and, oops, that's not a 9, 192,000. We have total variable cost that they've also given us of 99,840. We don't know fixed costs, total cost. We don't know total cost, and we aren't given net income. But remember, they're breaking even. And net income equals profit. And at break even, profit equals 0. So we know that net income must equal 0. So once we realize that if they're at break even, they're telling us net income equals 0, we can fill that in here. And suddenly we can figure this out, because sales minus total cost equals net income. So 192,000 minus total cost equals 0. So total cost must equal 192,000. And we also know that total variable cost plus fixed cost equals total cost. So 99,840 plus fixed cost must equal 192,000. So fixed cost must equal 192,000 minus 99,840. So again, we need a calculator. 192,000 minus 99,840, and we get 92160. I'm hoping. So 92160. So she could have fixed costs of 92,160 and break even. If her fixed costs are less than that, she'll make a profit. If they're more than that, she'll make a loss. But this is where she'd be breaking even. Please explain the calculation on the upper right corner. Well, what we know is in this chapter, they talk about net income, right? Net income. Which is annoying because in the previous chapter, they talked about profit, but net income and profit are the same thing. So we know that net income equals profit, but we also know that at break even, by definition, at break even, profit equals 0. So if profit equals 0, net income has to equal 0 because they're the same thing. And once we realize that net income is equal to 0, then we can fill it in down here. And that allows us to figure out all these other pieces of information. Does that help? It's just a little weird that they changed the terminology. we're talking about profit, then suddenly they're talking about net income, but they're exactly the same thing. I'm not quite sure why they do that, but suddenly we're talking about net income, but we just have to remember that it means profit. And what other nonsense have they come up with? So the management of Lambda Corporation has received the following forecast for the next year. So they've given us all the standard information here. Sales revenue, same thing. Fixed costs. They've talked about variable cost. They haven't called it total variable cost, but we have to realize that it still is total variable cost. Total cost is still those two added together. And net income is still sales minus total cost. They've also told us capacity, and they want us to compute a bunch of nonsense. So we'll start with the contribution margin because that makes life a lot easier. So our contribution margin is equal to 1 minus total variable cost over sales. And so that is variable cost is 270,000 over 600,000. Oh, I forgot the 1 minus. That's annoying. Equals 1 minus something. So 270,000 divided by 600. So 1 minus 0.45 equals 0.55. And once we know the contribution margin, we can easily figure out the contribution rate because it's just this turned into a percentage. 55%. And the break-even point is equal to fixed costs over the decimal value of contribution margin. So fixed cost was 275,000 divided by 0.55. What is that? 275,000 divided by 0.55 is 500,000. It hasn't asked us for the dollar value. Oh yeah, as a decimal and as a dollar amount. Yes, it has. Okay. So we'll calculate that. Contribution margin as a dollar amount can be equal to contribution margin times sales, which is 0.55 times 600,000. And we're getting 330,000, but we should also check whether it works the other way. It's sales minus total variable cost. So 600,000 minus total variable cost of 270,000. And it looks like it'll work out exactly the same. So we're fairly sure that our decimal value is correct because these two agree with one another. So we've computed the contribution margin as both a decimal, which was 0.55, and a dollar amount, which was 330,000. We've calculated the contribution rate as 55%. The break-even point in sales dollars, we found that to be 500,000. We haven't figured it out in sales dollars. Let's figure it out in sales dollars. Total revenue equals X, which is 500,000. And total cost equals fixed costs, 275,000 plus 0.45 times 500,000. Let's see what all that equals. 0.45 times 500,000 plus 275,000 and still gives us 500,000, which is good. And as a percent of capacity, what is X here? X is just a variable level of sales dollars, but in this case, we specifically solved for the break-even level of sales dollars. So the break-even level of X turned out to be 500,000. So when we're dealing with break-even, X is the break-even level of sales dollars. But more generally, X can be any level of sales dollars. And then we want, as a percent of capacity, so percent of capacity equals our break-even level of sales dollars, or break-even X, over what they've given us as capacity. And they have to give us something. They did. They gave us 800,000. So 500,000 over 800,000. And what does that work out to? Times 100. So I should put times 100, and it equals 62.5%. So the last thing they want us to do here is draw this annoying break-even chart. So first off, let's find all the numbers we need. We're looking at two equations: total revenue and total cost. And so we are going to create this weird mystical symbol. And we have to remember the points we're considering are when we're at 0% of capacity, when we're at break even, and when we're at capacity. And we're looking for dollars over here. But here we don't have quantity, so we're going to be dealing with percent of capacity. And we have to consider the equation we're dealing with. Total revenue equals X. And so we go through the same logical process of, if we're selling 0% of our capacity, we're going to be making $0. We've already figured out the break even. We figured out that it was 500,000, but this was 62.5% of capacity. And here we have, it's always got to be 100% of capacity if we're looking at percent of capacity. And they had to tell us that this was 800,000. Otherwise, we'd have no way of knowing. So we know all of the answers that go into this box. Over here, we have to consider, again, total cost equals fixed cost, which was 275,000, and our total variable cost over sales, which turned out to be 0.45 times this mysterious level X, which is our variable level of sales dollars. Although when we solve for it, it turns out to be the break-even level. And we have to realize that if we're at 0% of capacity, we've still paid our fixed costs. So in terms of cost, this is 275,000. At break even, we're in exactly the same position. We plugged in 500,000 into this cost equation, and we got our break-even level of sales as a percent of capacity as 62.5. Down here, we know we're at 100% of capacity, but this one here is tricky because we can't put 100 in, because 100 is the percentage. We have to figure out what our sales are at 100% of capacity, which we already know. These are our sales. At 100% of capacity, right? That's what you have to remember, that these are the sales, not 100. So we've got to plug in the the value of 800,000 in here. So total cost equals 275,000 plus 0.45 times 800,000, at which time we need a calculator. So 0.45, try that again with the calculator turned on, 0.45 times 800,000 plus 275,000, and I'm getting a value of 635,000, which can go in here. So once we have all these numbers, we can then draw our break-even chart. Let's take a look at how that would work. So we're still looking for dollars, dollars up here, which is total revenue and total cost. But down here, we're looking for percent of capacity. And so this axis for total sales dollars will always look the same. It'll always go to 100. So we can fill that in 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And whatever numbers you're going to use, make sure you put them on the axis. So then go to your chart and do the total revenue first, because that's going to go up the highest. And we can see it has to go up to 800,000. So I'll be going up in 100,000s, I guess. 1, 2, 3, 4, 5, 6, 7, 8. So 800,000. And then we can try and find this first point here, somewhere vaguely like here. If you have graph paper, it makes it nicer. This is our other point that we know. And then we've got to find 500,000. 1, 2, 3, 4, 5. So there. And 62.5. So 10, 20, 30, 40, 50, 60. So somewhere vaguely like here. 62.5. And we try to pretend we can draw that point. And then we take a straight edge and see if we're anywhere near a straight line. Well, we sort of missed this one, but don't worry. As I said, it doesn't have to be a work of art. But this has to have a label, total revenue. And then try and do the same thing for total cost. When we're at 0, we're at 275. So 1, 2, 3, somewhere vaguely like here. We've already got this point, even though it sucks. And 635. So 1, 2, 3, 4, 5, 6, 7, 635. I'm going to say somewhere like here. And try to draw that point. then take your straight edge and see how bad that is. Well, that one's a bit better. Total cost. And draw attention to the break even. Tell people this is where we can make a profit. This is where we'd be making a loss. And draw some kind of a line here. I usually draw a dotted line when I'm doing it by pencil, and it doesn't matter that this whole nonsense here doesn't quite line up. If you ever produce one for a business plan, of course, you'll get some professional to do it and it'll look perfect. This one certainly doesn't have to. So any questions on what we've done there before we change horses totally and do something totally different for the next hour? I will give you one word of caution. When you're dealing with the questions out of the textbook, the contribution margin always works out to be a really nice round number. When you're working with the questions that I've given you to work with on Moodle, they don't always work out so nicely, but you can never round them off. Keep that contribution margin to as many decimals as possible, and then you'll find out that things will work out a lot better. Don't round it. They've been really nice in giving you things that work out to nice round numbers, but on many of the questions that you'll have to deal with in the homework, they don't work out so nicely. But don't round it off at all, and then it'll work out better. So let's clear all that nonsense. And now let's take a look at what we have for the compound interest assignment. We're now finished with chapter 5. We spent about 5 weeks specifically dealing with chapter 5. And so now we're dealing, or not, sorry, in terms of compound interest, we spent about 5 weeks dealing with chapter 13. And now we're going to deal with chapter 14. And we cover the whole chapter today. So hopefully we'll be able to make it make sense. Let me go and find those assignments. Where did we hide them? So I'm hoping that we're all looking at a, I'm hoping that we're all looking at a spreadsheet now. If we're not all looking at a spreadsheet, let me know as soon as you can. Let's find the chat box so you can communicate with me. Okay, that's good. Let's enlarge this so we can read it. So let me first off try and give you an idea of what an amortization schedule is. When you buy a house or a piece of property, or it could be any loan, but it's typically with a house or a piece of property. You take a loan out from the bank, and every month, or if it's monthly, usually it's monthly, but in this case, it's semi-annually. But every so often you make a payment, and out of that payment, the bank first off takes their interest that has accrued on the loan, and then what's left over from your payment, they apply it to the amount that you owe. In other words, they take it away from the balance. And then everything stays the same until your next payment. And again, they do the same thing. They take your payment, they take the interest away, which is the amount you owe them, and then they take the rest of your payment and apply it to the loan. And when they put this on a spreadsheet, it's called an amortization schedule. So we're going to be working with amortization schedules today. But of course, the first thing we need to know is what is the size of the payment? So in this case, the contractor's price for a new building was $96,000, and Slade Incorporated, the buyers of the building, they paid $1,200 down. So they paid that money up front, and they'll owe the rest, and finance the balance by making equal payments at the end of every 6 months, so semi-annual payments for 12 years. And interest is 7.3% compounded semi-annually. So we know it's at the end of every 6 months. So this is an ordinary annuity, not an annuity due. And it's compounded semi-annually, and the payments are semi-annually. So it's a simple annuity, not a general annuity. So armed with that information, let's see what we're going to do. So the first thing we have to do is find out how much the payment is. So if we're solving it by hand, we're using formula 11.2a, and the payment is equal to this nonsense. And if we plug in all these values, and you can try it at home, see if it works. And if it doesn't work, please let me know. But you should get a payment of $5,313.66. Notice for the present value, we took the $96,000 minus the down payment. So they're really only borrowing $84,000. So I'm sure that will work for you. You could do it on the BA2 plus. It's an ordinary annuity, so we don't want BGN up. So if you need to get rid of BGN, this is how you're going to do it. And we've plugged in the information. Payments per year is 2, semi-annual, and it'll automatically make the compounding 2 if we don't set it separately. 24 payments, the interest, the amount we're borrowing, and 0 future value. And we compute the payment and we get the same answer we got up there. So that's good. Or we could do it on Excel, because Excel will let us calculate the payment. And we have to calculate the rate. Notice for the BA2 plus, we could just put in the 7.3, but here we had to go 7.3% divided by 2 and come up with an actual periodic rate. The periods are still 24, present value is still 84,000. Future value still has to be 0. And with type equals 0, we're telling Excel it's an ordinary annuity, not annuity due. And Excel will come up with exactly the same answer. notice both Excel and the BA2 Plus come up with a negative amount because that's the amount we have to pay. So then they want us to calculate some other nonsense. For the first payment period, how much interest is paid? How much of the principal is repaid? And what is the loan balance? And of course, as I said at the beginning, this is how amortization works. You take the, find the amount of interest, take it away from the payment, apply what's left to the principal, and come up with a new loan balance. So that's what we're doing here. To calculate the amount of interest, multiply the outstanding balance, which was 84,000, by the rate, and come up with the fact that we owe, after 6 months, $3,066 interest. So the bank says, that's fine. We know the payment was $5,013.66. So the first thing the bank does is take its pound of flesh, it's $30.66, and what we have left over is $2,247.66, and we can apply that to the outstanding balance. So after the first payment, we only owe 81,000. And so everything stays the same for another 6 months until we make another payment. And then exactly the same calculation happens. They take the outstanding balance, which is now 81,000 something. They multiply that by the interest rate, and they find that now we owe them $2,983. They take our payment of 513 minus the interest that we owe, and they come up with how much is left over from our payment, which is now slightly more than last time. And they take it away from the outstanding balance. So now we only owe $79,422.64. So this is going to go, if we did this for 24 times, then we would have completed the entire amortization schedule. This is the first payment of the schedule. All this would go on one line, and all this would go on the next line. But now they've asked us, what is the total cost of the building? Well, we know the payments we're making. We're going to multiply it by 24 payments, 12 years, twice a year. And we find out that we're going to really pay $127,527.84. And so once we know the total amount we're going to pay, we could figure out how much interest we're going to pay, because we're paying them $127,000, but we really only borrowed $84,000. So out of the total amount that we paid back, 43,000 and something is the interest. So any thoughts, concerns, cries of agony, moans of despair at that point? Okay, let's move on and take a look at what they've done to us in the next one. Let's enlarge it. So something called Apex Corporation borrowed 85,000 at 8% compounded quarterly for 8 years to buy a warehouse. And equal payments are made at the end of every 3 months. So again, it's compounded quarterly, and the payments are being made every 3 months, so they're quarterly. So again, this is a simple annuity, not a general annuity. And payments are made at the end of every 3 months. So it's a ordinary annuity, not an annuity due. So we always have to make sure that we're using the right formulas by making sure we know what it is we're dealing with. So determine the size of the quarterly payments first. And again, we use the same formula. If we calculate it by hand, we should get $3,621.90. If we use the BA2 plus, we should get exactly the same answer. It starts out negative. I obviously made it positive, but it will come back to you as a negative number. And if we use Excel, we have to calculate the rate ourselves, but we should get exactly the same answer. Notice it comes back to us as negative. I've made it positive here, but the calculator will give it to you as a negative amount. So now they want us to do something weird here. They want us to compute the interest included in the 16th payment, which is annoying because there's 32 payments. So the first thing we have to do is, of course, find the payment, but we've done that. So we're good to go there. And our plan here is to find the balance after the 15th period, because if we know the balance after the 15th period, then we can find out how much interest we're going to pay on it in the 16th period. So this is a complicated process. We find the future value of the 15th of the principal at 15 periods. So the future value, the present value of 85,000, the interest rate, but instead of going for 32 periods, we're only going for 15 periods. So we find the future value of the principal would be 114,000 and something. So we know the future value of the principal. Now we find the future value of the payments. So we plug everything into this formula using our payment that we calculated, and we find out that the future value of the payments would be this much. And then we subtract the future value of the payments, which is what we're paying, from the future value of the principal, which is what we owe. So this minus this, we end up finding out the balance after 15 periods. And so once we know the balance, we can find out the interest that would accrue on that, just like we would if we were producing the whole schedule. And so the interest ended up equaling the principal, which we just calculated, times the rate, which we calculated, times the time, which in this case is 1 period. And we come up with 1,035.28. So that was a fairly complicated process to do this by hand. Let's take a look at how to do it on the BA2 plus. Again, step 1, find the payment. Step 2, find the future value of the principal. Here we know we're going 15 payments. We know the interest rate. We know the present value. We make the payment here 0 because we're only looking for the future value of the principal. And so we calculate for the future value, And amazingly enough, we come up with the same 114,000. So step 3 is we find the future value of the payments. Again, N is 15, the interest rate is 8, but now we make the present value 0, and we fill in the payments, and we solve for the future value, and amazingly enough, we come up with the same 62,000. Then we have to do the same calculation. We subtract the future value of what we owe from the future value of what we've paid and come up with where we would be after 15 payments. And we get basically the same answer. And then we can do the same calculation. We find out how much interest we would pay on that in the 16th payment period. And we come up with the same answer. And we could do the whole thing on Excel. Same scenario. We have to calculate the rate ourselves. The number of periods is 15. To start with, we make payment 0 because we're only looking for the future value of the principal. And we solve for the future value, and we still get that 114,000. Step 3, the same concept. In this case, we fill in the payment, but the present value here is 0 because we're only looking at the future value of the payments. So we make the present value 0, and we still solve for future value, and we come up with that 62,000. And then the same concept. We have to subtract the future value of the principal from the future value of the payments to figure out where we'd be after 15 payments. And we come up with the same answer. And then we can use that value to figure out the interest on that amount. So it doesn't matter whether you do it by hand, by the BA2 Plus, or Excel. It's still the same process. You have to go through 4 steps to figure it out. And then they're going to do the same thing to us. They've asked us about the principal repaid in the 20th payment period. And we got to do all this nonsense again. Figure out the future value at 19 payments, the future value of the payments at 19 periods or payments, take one away from the other to see where we are, calculate the interest, which we did just like we did last time, but here they want us to do one more step. They want us to subtract the interest accrued from the payment. So we know the payment because we figured it out in step 1, minus the interest. And what we're getting here, this answer, is this is how much money we'd be taking off the principal. So a fairly lengthy, time-consuming process. And I've done the whole thing on the BA2 Plus, the whole thing on Excel again. And we keep adding, or we keep taking this away from the payment to get how much we're taking off the principal. So then we get to something called construct an amortization schedule. So an amortization schedule, and I've got to shrink this down a little so we can see this periodic rate. What we're going to do is we figure out the number of payments, and notice here it's 32 payments. The amount paid is our payment, so we figured that out. and that's going to be the same all the way down. The interest paid, when we look at this calculation, what we're doing here is we take the outstanding balance, we multiply it by the rate of interest, and we round it to 2 decimals here. And that's going to be the same every time. Notice it takes the new balance, multiplies it by the rate of interest every time. Takes the previous balance, multiplies it by the rate of interest. So notice what happens to this column. The amount of interest you pay goes down because the principal outstanding is going down. Then in this column, the principal repaid, all we're doing is taking the payment minus the interest, and what's left over is the amount we can take off the outstanding balance. Then in order to get the outstanding principal, we take the amount we owe, the previous balance, minus the amount that's being taken off of the principal, and we get the new balance. And so this whole sort of calculation, once we know what these things are, we got to figure out this one, and this one. In order to produce the table, we know we're going 32. We know this one is just equal to this all the time. So once we know these ones, we can just copy this down. And that's how we would produce this table. We'd have to copy each of these columns. And we would copy this one down. And we would copy this one all the way down. So once you've got the first line of the schedule, then you just copy it all the way down, and we'll have to do one that hasn't been already completed. And the numbers that we had above that we calculated, we find them showing up down here, right? This was the 16th payment and the 20th payment. These numbers will show up here. The only place we have to do anything different is for this last payment. Notice this payment is not the same as all of the others, because we have to take the principal plus the interest and add them together. If we didn't do that, we wouldn't end up with a balance of 0. So we've always got to make a slight adjustment on the very last payment. And then we can add these columns up. This is just the sum of this entire column. And this is the sum of this entire column to get the total amount paid and the total interest paid. Now, notice that if we compare the total amount paid, we would get, by multiplying the payment by the number of payments, we get a slightly different answer. Because here we can see there's this extra 6 cents. But in reality, that 6 cents would be added to the final payment. So the answer we got here, this total, is in fact a better answer than we would have got by just multiplying our payment by 32. this extra 6 cents, amazingly enough, the bank is going to make you pay that 6 cents. So doing the amortization schedule actually gives you a better answer than just this straight calculation. So until you've tried to produce a few of these amortization schedules, you probably won't have any questions dealing with them. But you can see what I've done here because you've got this file, this Excel file. So hopefully you'll be able to make sense out of what's happened here. I put the periodic rate over here on the side. It just makes it a lot easier. So on calculating the interest that would accrue on the principal during the 20th period, why was it multiplied by 1? Where did that value of 1 come from? Here, by 1. This formula here, PRT, is the principal times the rate times the time. And in this case, the time is going to be the number of periods involved, right? So we're only worried about the principal for 1 period. I could have just done interest equals principal times the rate. Might have made more sense. But the usual formula that we use for figuring out the interest is principal times rate times time. So I didn't want to miss out the time on this writing of that formula. But in this case, it just equals 1 because it only represents 1 period worth of interest. Not really sure. Let's see. Yeah, not really sure how else I could have done that time.
But would it always be 1?
In these calculations, yes, it'll always be 1.
Okay.
Later on, we'll deal with situations where it's not 1. But as far as figuring out just 1 period of interest, it'll always be 1.
Okay, thank you.
Yeah, we will work with situations where it's not 1, but here it will always be 1. So, any other questions on what we've done there before we take a look at all of this nonsense we've done here? In the next question, I'll show you how to do it a lot more easily because your calculator is programmed to do this for you. So let's look at the next question.
Mr. Brown, sorry.
Yeah.
On the amortization schedule, could you kindly show how to compute for interest paid, principal repaid, and outstanding principal balance? Like just the payment number 1.
Sure.
Thank you.
The interest paid, I don't know whether you can read this up here, but we can see that it's the outstanding principal, right? The 85,000 times the periodic interest rate of 0.02. In other words, if we take 85,000, so take a calculator and multiply 85,000 by 0.02 and see what we get. See what you get. 85,000 times 0.02. And what do you get?
$1,700. Okay.
Right. And that's that answer. And then let's do the next one. Take the outstanding balance of 83078.1 times 0.02. And you should get this number here. Does it work?
Yes.
Yeah. So that's how this thing is always calculated. The previous balance times the periodic rate. And in this case, there's no one involved, although it could be there, but there's no need for it. But every time we're taking the previous balance times the periodic rate. That's why I make a column of the periodic rate out here. It's just easier to reference it in Excel. And now for the principal repaid, notice all we're doing is we know the payment of 3621.9. In this case, the bank took 1,700, and this is what we're left with. 1921.9. Does that make sense?
Yes, so amount paid minus interest paid is equal to principal repaid.
That's right. That's what's left over of your payment after they've taken their interest. And then the next one, the outstanding balance, take the previous balance, which was 85,000, minus the principal repaid, 1921.9. And this is how much we're still owing. 83,000. Oops. Oh yeah, and $78.10.
Okay, got it now. Thank you.
And then that just continues on every time. The amount paid stays the same, but these three calculations have to happen every time. Okay, so let's take a look at what we're doing here. A debt of 45,000 is repaid over 15 years with semi-annual payments. Interest is 9% compounded monthly, and we're going to use the amortization program in the BA2 Plus to answer the following questions. So the first thing we notice is this thing is a general annuity because they're semi-annual payments, but the interest is compounded monthly. Now, so we notice it's a general annuity. When we're deciding whether it's an ordinary annuity or an annuity due, this question does not specify beginning or end, but the textbook tells us that mortgage payments are, they say, generally at the end of the payment period, and that's how they work. So we will assume end of period payments unless specifically told beginning. So although they didn't tell us, they do tell us, assume it's end of period unless they tell us differently. So the amortization program on your BA2 Plus is all concerning, if you'll notice, the second function of the present value or PV button. Above it, there's this little word amort. And so we get rid of the BGN. So make sure BGN is not up. And always set your calculator to 2 decimals. Notice when we looked at the amortization schedule, let's look back at it really quickly. When we looked at this schedule, we've rounded all of these numbers to 2 decimals, right? And we need our calculator to do the same thing. So before doing anything with amortization, set your calculator to 2 decimals. And before we can do anything else, we need to know the size of the periodic payment. We're only doing this on the BA2 plus. And notice we have to set PY and CY separately because it's a general annuity. We had to figure out it was 30 payments. The interest is 9. 45,000 is the present value. We don't know the payment, but we know that eventually we owe no money. We compute the payment and hopefully we get 2,790.38. So you want to do that on your calculator. So before we do anything else, do that so you can see how the next step works. So second PY 2, enter, down, 12, enter, clear a couple times, 30 into N, 9 into IY, 45,000 into PV, 0 into future value, and compute payment. And I got some ridiculously stupid answer because I forgot to set my calculator to 2 decimals. So I'll set it. Second, format, 2, enter, clear, and now compute payment. And I get negative 2790.38. So if you're not getting this answer, let me know, because everybody needs to be looking at this on their calculator before we do the next step. Are we good? I will take silence as everybody's good. So if you're not good, now's a good time not to be silent. Good. Now let's take a look at how we use this. So when calculating amortization schedules with the BA2 plus, the balance, the principal repaid, and the interest all appear as negative numbers, but we can ignore the negative sign. So think back to the previous question of all the work we had to do, that's step 1, 2, 3, and 4, and then some adding and subtracting to find out the balance and the interest at a certain point. So what is the balance after the 11th payment? Go second and then hit amort. And you have to have done the payment first. So you've done the payment, go second amort, and P1 is period 1. We're going to put 11 and go enter, hit the down arrow. And for period 2, we're also going to go 11 because we're only focusing on the 11th payment. Go enter and down. And now you're looking at the balance. 34,892.31, correct? Anybody not looking at that? Now, for some weird reason, although I've just said it's going to be negative, it's not negative on my calculator, so I'm good with that. So, and they want to know the interest paid during the 12th payment. So again, just go second, amort, and in this case, instead of 11, put 12, enter down 12, because we're only worried about the 12th payment, enter down, and we get the balance, but we don't want to know the balance. Hit the down arrow. We get the principal, which shows up with a negative sign, but we can ignore the negative. And we hit the down arrow again, and we get the interest, which shows up with a negative, but we're not worried about the negative. So notice how much work that did for us compared with what we did in the last question where we did it by hand. And then they say how much principal is repaid in the 12th payment. We can see it here. We can see 11. Oh, I've given us the balance as the answer here, but how much principal is repaid in the 12th payment? If we hit the up arrow and look at principal, so this number here is wrong. This is the balance. We didn't want the balance here. We want 1190.49. So whenever you're trying to produce the amortization schedule, you can produce an amortization schedule by using your BA2 plus. In fact, let's go ahead and do that. Let's go hit Amort. Oh, that didn't work. Second Amort. So you have to go second Amort. If you do P1 equals 1, enter down, and P2 equals 1, enter down, then we'd be getting the information for the first line of our amortization schedule. So you could produce the whole schedule just by doing P1 equals 1, P2 equals 1. That would give you the first line. And then P1 equals 2, P2 equals 2. That would give you the answers that would go in the second line. And you could work it all the way down by using this. But usually what they ask you is things somewhere in the middle of the schedule. So you just take whatever number they've given you and look at just that line of the schedule. So any questions you can think of asking about how to use that BA2 plus to find numbers in that schedule? It does an amazing amount of work for you. Let's see what they're giving us in the next question. So an annuity with a cash value of 10,500 pays 900 at the beginning of every 3 months. The investment earns 11% semi-annually. So in this case, they've told us the payment is 900. And we know the present value is 10,500. We can see that this is a general annuity because compounding is semi-annual. Helps if I spell semi-annual right. And payments are quarterly. We can also see that it's an annuity due. because payments are at the beginning of every 3 months, not at the end. So this is an annuity due. So how many payments will be made? We have a formula to solve for the number of payments by hand. When we find out that it would be 13 point something payments, which really means it'll be 14 payments, although the last payment is just a partial payment. We could do this on the BA2 plus. In this case, we have to remember that we need BGN up. So we have to go second BGN second set. And it's a general annuity, so we have to set PY equals 4 and CY equals 2 separately. The interest is 11. The 10,500 is negative because we're putting that money in. The $900 payment is positive because we're getting that money out. And again, we find out that it's 13 point something. Notice my calculator is set to 2 decimals, but we round it up to 14 anyway, because it'll be 14 payments. And we could do the same thing on Excel. We solve for N per. Notice this rate here. Where did this weird rate come from? Where did I get that rate? Because this is a general annuity, we have to solve for the value of P. So we know I, we know C, and P equals 1 plus I to the power of C minus 1. So we need to know this. We needed to know it for the hand calculation because these all had to use P. We didn't need to know it for the BA2 plus. But for Excel, we need to know it again. This is the value of P. The payment we know, the present value we know, the future value we know is 0. The type has to be 1. That's how we tell the computer that this is an annuity due. We still get 13 point something, and we still round it up to 14. So however we decide to do that, we're going to get a payment or an answer that says 14 payments. So we're going to produce an amortization schedule. It's a bit annoying because it's an annuity due. So notice for an annuity due, there's going to be no interest paid on this first amount because this first amount is paid at the beginning of the payment period. So there's no interest accruing on this. So you're going to use exactly the same schedule you did for annuity, for the ordinary annuity, right? But then just replace this first payment with 0. And then suddenly it turns into an annuity due. And notice if we shrink this a little, our periodic rate here is the value of P because that's just the way it has to work. So once we made this 0, this one turns out to be exactly the amount of the first payment. And then after that, we'll be calculating it just the same as we did previously. So it's just a little bit annoying that you have to remember that if you're dealing with annuity due, this first interest payment is going to be 0. But set the table up exactly the same and then do it as 0. notice when we get to the bottom here, we have to do a little bit of work because we knew that this payment, this final payment, was not going to be the full amount. So we had to take the remaining principal, the outstanding balance, plus the interest, and we find out this last payment is only $688. So that's how to do this if you're going to produce the whole schedule to figure out, what did they ask us? The final payment. So we could also do this using the amortization schedule in the BA2 plus. Let's get this information into our calculator. So BGN has to be up. So second BGN, second set to make sure BGN is up. Calculator has to be set to 2 decimal places. And so plug this all in. Second, IY, 4, enter down, 2, enter, hit clear a couple times. We don't know N, but we do know we're making, or the interest rate is 11% into IY. We have to put 10,500 in, so it's negative into present value. We're getting 900 out into payment, and eventually we owe nothing, so future value is 0, and compute N, and you should get 13.76. If you don't, now's a good time to freak out. So we're going to round up the payments to 14 payments. So instead of looking at N equals 13.76, type in 14 and then hit N. So now N equals 14. And then once we've changed it to 14 payments, because we can't make 13.76 payments, then we'll continue with the amortization schedule. Go second, amort. And we're only worried about the 13th payment and the 14th payment. So set PY equals 13, or P1 equals 13, enter down, and P2 equals 13. 13, enter down. When we get a balance, it may be negative on your calculator, but you can ignore the negative. Hit the down arrow, but we need to make a note of that balance. Hit the down arrow, we get 858.52, fine. Hit the down arrow, we get 41.48, which is good. And hit the down arrow again, and we're looking at P1 equals 13, but change it to 14 now. 14, enter down, 14, enter down. And we're looking at 211.62, down arrow, 88182, down arrow, 1888. So we've got to take these two numbers, the balance of 670.2 and the interest, and we've got to add them together to get that final payment. So we add them together and we get 688.38, which is what we got up here when we looked at these numbers here. So if you're being asked to find the final payment, then you can do it using the BA2 plus, or you can do it by creating the actual schedule and making this final adjustment in that final period. Now, they also tell you how to do it by hand, and we'll take a quick look at that, but I can't imagine you're going to do this. And there's two reasons. One, it's very painful, and two, it doesn't give you an answer that's usually exactly correct, which is really annoying. But the BA2 plus and the schedule give you the correct answer. The calculation by hand does not. We calculate N by hand, we get 13.76. But notice, we're worried about the final payment. So we're only worried about the decimal portion of this. So although it was 13.76, we go minus 13, and we're only worried about this decimal portion, but don't round it off, because this decimal portion represents that partial payment. Then what they do is we're looking for the present value of the partial payment. So we still have to be using P, but N is now this decimal value that we've saved, and the payment is 900. And notice we come up with 688.39. We'd have liked 38 because we know the actual answer is 38, but for some reason, calculating it by hand, we're 1 penny out in this method. They have another couple methods. This is method 3. I don't know what I did with method 2. I guess I ignored it. But in this method, we have to find the future value of the amount, the original amount. And in this case, we're still using N equals 14. And we come up with the future value for the entire schedule. And we find the future value of the payments. We have to use the annuity due formula. So this 1 plus P is hanging around out here. And we have the future value of the payments. And we calculate this overpayment, the future value of the principal minus the future value of the payments equals an overpayment. And we subtract the overpayment from the regular payment. And we come up with 682.64, which is still a wrong answer. It's close, but it's wrong. So although they give you various ways of calculating these things by hand, calculating it either on the BA2 plus with your calculator set to 2 decimals will always give you exactly the right answer, or creating the actual schedule on Excel and rounding all the answers to 2 all the way down and adjusting the final line will give you exactly the right answer. So I can't see that you're going to spend much time trying to do those calculations by hand because it's a lot of work and you end up getting the wrong answer. How do we calculate the total interest paid? If we have the schedule here, let's create some more lines. Insert. This is the interest paid, right? We can just go equals sum of this column. And that should give us the total interest paid. So that would be one way of doing it. Let's take a look on the BA2 plus, what we'd have to do. Let's give us some space here. Whoops, it's a lot of space. Let me grab all this and copy it, and I'll adjust it to show the total interest paid. So here we did second amort, and we did P1, right? And we focused in just on the 13th payment. Make this 1 and make this one 14. So what we're going to do is we're going to look at, instead of just looking at one period, we're going to look at the whole thing. So now let's go back to our calculator. Let's, we haven't done anything else. So we should still have this in our calculator. So go second amort and go 1, enter down. And now 14 is the last payment. 14, enter down. And I'm getting a balance now of 211.62. Are you getting the same balance? Okay, hit the down arrow. And I'm getting the principal paid of 10711.62. And then hit the down arrow, and I'm getting 1888.38. Are you getting the same? Yeah, up here we got 1888.38. Oops, and down here we're getting 1888.38. So this would be the total interest paid. Notice these numbers are a little weird because here's that overpayment. Remember when we calculated, we found there was an overpayment, and the principal says we've paid slightly too much. So these two numbers don't make a whole lot of sense because of that overpayment. But the interest works out perfectly, strangely enough. We'd have to go 10711.62 minus 211.62, and that would give us our actual balance. Because here, because we've gone the full 14 payments, we in fact look like we've paid too much money. Could you solve this on the BA2 plus? Yes, this is the BA2 plus. We did solve it on the BA2 plus. So when you say, could we solve this on the BA2 plus, what is it you want us to solve? Sukhbir. Okay, I didn't understand. But do you understand now that this, what we've done here, this is all on the BA2 plus. This is how you would do it using that amortization button, which is the schedule. And if you need to get the whole picture, this is how you do it. Set P1 to 1 for the first period and the second period to the last period, and then that'll give you the whole. You want to see this calculation on BA2 plus. Okay. Oh, okay. Sorry. I'm so sorry. I see what you mean. You want me to fire up my calculator. Good. Got it. I was a little slow on the uptake there. My apologies. Okay, so are you looking at the BA2 plus calculator?
Yes.
Okay. Okay, so first off, we have to find the number of payments. So I got to clear this. BGN is up. BGN is already up here. And I got to set my calculator to 2 decimals. So second, format, 2, enter, and hit clear a couple times. So don't hesitate to slow me down if I go too fast. Then I've got to go second, PY, quarterly, so 4, enter, down, CY equals 2, so 2, enter, and then I hit clear a couple times to get rid of that. We can't put anything into N, but we know the interest is 11, so IY. We know the amount is 10500, but this is money we had to put in, so it's negative. It came out of our pocket into present value. We're getting 900. So the 900 is the payment, and it's positive. And once this annuity is run out, there's 0 money left. So 0 into future value, and we compute N. And we get the 13.76. But we don't want to deal with 13.76. We want to deal with 14 whole payments. So just go 14 into N. And then we can go second, and it's the second function of PV, this word amort. So present value equals 1, or not present value, sorry, period 1 is 1, but we're looking for 13. Let me see if I can bring up the next part of this. So we want this to focus on period 13, enter, down, and we want the next one to be 13, enter, down, and here's our balance, 620 or 670.2. We're not worried about the negative sign. Hit down arrow again. This is the principal repaid is 858.52, and hit the down arrow again, and we get the amount of interest of 41.48. So we hit the down arrow again, and we're still looking at P1 equals 13. but we're going to make it 14. Enter down. And we want this one to be 14. Enter down. And here's our 211.62. Hit the down arrow. 881.82. Hit the down arrow. 1888. And these are the two numbers we wanted. We wanted the 670, which is the balance, plus the interest of 1888. And we add those two together to get the final payment. Does that help? Let's take a look at the whole picture here. If we wanted to look at the whole picture, we'll want P1 equals 1. So we'll start with the first period. We've already got P2 equals 14, so enter and down. And this will tell us the balance after 14 payments. But in this case, it's not 0 because we've paid an extra $211.62. The down arrow, the principal repaid, notice again, it's 107.1162 because it says we've paid an extra $211, but we've paid exactly $1,888.38 in interest. In order to make sense out of the principal and the balance, we'd have to take the overpayment away from the principal, and that would make sense. But the calculator hasn't done that for us. So, Sukhbir, does that help a little?
Yes.
Okay. So let's take a look at the next question we're doing. Question number 5 here. Take the split away. That looks terrible. A lot of nonsense happening. Let's enlarge this. So the Littles purchased a home. They borrowed $170,000 as a mortgage to be amortized by making monthly payments for 25 years. Interest is 4.89% compounded semi-annually for a 3-year term. So we have to find the size of the monthly payment. We can do this by hand, by BA2 Plus, or by Excel. It doesn't really matter which way you do it. But then they want us to determine the balance at the end of the 3-year term. Now, you can do this by hand, but we know that's rather painful. We can find the future value of the principal, the future value of the payments, and subtract one from the other, and we get an answer. We can do this on the BA2 Plus. We have BGN is not up. Calculator set to 2 decimals. We find the payment. And then 3 years, but it's monthly, would be the 36th payment. So notice what we did. We set first period to 36, the second period to 36. So we're focused in on the 36th payment, and it gives us the balance, the principal, and the interest, but we're worried specifically about the balance. And we get an answer that's close to the one we got by hand, but this answer is in fact more accurate than the hand calculation. So stick with the BA2 Plus to do that. If we had to do it on Excel, we would have to create an amortization schedule. This is not zero because it's not annuity due. And these calculations are the same. But let's shrink it a little so you can see where the interest is coming from. You need this periodic value. And it's a general annuity, so this has to be the value of P. But notice, once you've got this first line and you've copied all of these down, we're only looking at the first 36 payments. And we get this answer here, which if we split this screen, is the same as we got this answer here, but not quite the same as when we did it by hand. So keep in mind that the BA2 Plus and your Excel schedule are more accurate than the hand calculation, which is kind of annoying, but it's just the way it works out. So then they said, if the mortgage is renewed for a 4-year term at this new interest rate, still compounded semi-annually, what is the size of the monthly payment? So again, because they've changed the interest rate, we have to recalculate the value of P. So that calculation we just have to do by hand. And we find the value of the payment. We could do it on the BA2 Plus. The nice part about the BA2 Plus is we don't need the value of P. Right? We just can put in the 5.24. For the present value, though, we have to start with the value at the end of the first 36 months. So this isn't the original amount they borrowed. This is the amount they have left over after 3 years of payments. And so the original amount they borrowed, or in the original calculation, we did 300 into N, but now we're down to payments of 264. And we come up with a new value for the payment. And we could do it on Excel. On Excel, though, we have to have the value of P. The number of payments is 264. It's an ordinary annuity, not annuity due. And we come up with the same answer. So I will leave you with all of that nonsense. And sometime between now and when you write your final test, I'm quite sure you'll have either figured out how to deal with annuities, or you'll be spending a lot of time sending me messages. But I've used up all the time I'm allotted to torture you for one day, so I'll have to say goodbye now. So we'll stop that. And good luck on Friday.
Thank you, sir.
Okay, take care and study hard, I guess, even though the weather is so nice. Nice here in Vancouver anyway. I don't know what the weather is like where you are at the moment. Yes, I will post the recording on my YouTube site. When we stop today, that recording will take a little while to digest, but sometime this afternoon. During the exam or homeworks, are we going to be asked to create a full amortization schedule? No. You'll just have to find bits and pieces of the schedule. I will never get you to plug in all those numbers into Excel. That would be ridiculous. cruel, unusual, and ridiculous. So although it's a good idea to be able to create that whole schedule, because that gives you a visual image of the whole picture, but you'll never be asked to plug that all into Moodle. Any other interesting questions? Once you learn how to use the BA2 Plus, amortization questions are incredibly straightforward. Just make sure you've got your calculator set to 2 decimals. Okay, in that case, good luck. I will see you on Friday. Or at least I will see evidence of your work on Friday. Take care.
Thank you, Mr. Brown.
Thank you, sir. Thank you so
Okay,
much.
thank you.
Thank you, sir.
Thank you.
Okay, bye now.
Thank you, Mr. Brown.
I'll end this
Thank you,
and
sir.
have a good day.